sides in an angle, which is another law of cosines case. You guys saw your 11.06, 23.13, and 51.87. Number 34, given three sides, you can still use law of cosines. They used the rearranged one. You could have used the original and rearranged it. Angle B, angle A, 180 minus those two gets you angle C. Number 36. You're given two angles in one side, so why didn't they use law of cosines? Law of cosines is only good when you have at least two sides. So they said, forget it, use law of sines. You can use law of sines, that was appropriate. They use law of sines in order, well, they used that three angles in a triangle add up to 180 to find angle A. They set up law of sines and found their two sides. Good? Number 38. They use the area formula, the special area formula. Andrew and Colby, you should be very focused in grading your homework, or else you should be very quiet so I don't realize that you don't have your homework ready to grade. Awkward. Number 38, area formula, plugging in semi-perimeter and then solve, 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 when we get 399.04. 56 was a little funny because what were you missing? How many quantities were you missing when you went to go plug in? How many variables were there in the law of cosines? Okay, well, guys, formula. How many variables? How many letters? Two. Whoa, where are we? What's going on? Let's just pause. Let's pray. I don't know what's going on. I don't know. I'm still lost right now. Let's pray. Father, Lord, praise you for this pre-cal, honors pre-cal class grade. I think kids are tired, or they're out of it, or they're really behind, and they haven't, for one reason or another, caught up. Pray that as we go through class today, that we can use our time wisely and well, and do some math now for your glory. Lord, we pray that you will continue to impress on our hearts who you are, who your Son is, who we are in light of that. The brokenness in the world and how there is victory through Christ. Just pray that even though spiritual emphasis might not have been as founded on the scripture as it could have been, there was still wise, practical advice that was given, verses that were shared, testimonies that were expressed of lives committed to Christ. Just pray that those can bear fruit in our lives as well. Once again, wake up the kids, keep them alert. May we now do some good work excellently for you. In Jesus' name, amen. All right. What number are we on? Some of you might have been grading 66. Come back. I asked for number 56. It was a little weird. I'm totally agreeing with that. Why was it weird? That was the question I first asked and got no reply, at least nothing that I could audibly hear. My second question was, okay, I'll lead you a little bit. I do this a lot in class. And I said, okay, well, how much was missing? I still didn't get an answer. So then I said, how many variables are in this line? And then I still didn't get a clear answer. And finally, Thomas said 2. 2 what? Variables. I don't know x, and I don't know theta. Are we tracking? Yeah. Okay. Did that make it weird? Yeah, because we usually have an equation with only one unknown. And if we do have 2 unknowns, how many equations are we used to being given? 2. So it's like, this is impossible. No, they gave us a problem where? Okay? Where they wanted us to go ahead and plug and chug. Okay, we plugged and chugged what we had, and here's the formula. Simplify as much as possible. Okay, get everything to one side and solve for 0. And how on earth did they make this jump? Which looks a lot like an example from notes. Quadratic formula. X equals, wait. Who's not there besides the x? The 3 cosine theta. So x equals negative b plus or minus square root b squared minus 4a. It's a 1 and c, and that guy over 2a. And once they have this, they said, hey, okay. So you don't know what theta is, but you do know the equation that if you did know theta, you could solve. Hence, we could say, we have this whole, now they simplified it, yada, 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 whatever's. They want you to throw this into your graphing calculator, pretend that x is a y, and say, hey, look, throw them in and see what's going on. You're like, okay, fine. And then they want us to find the maximum, and the maximum, okay, couldn't we just use our little feature to find the max? When you find the max, you get 8.5 inches. I agree, it was weird, it made you think just a little bit. It wasn't impossible. Last but not least, more than 2 sides, law of cosines is good. More than 2 angles, or more than, I should say, only 1 side, you better use law of sines. 2 sides, you could have actually used law of sines or law of cosines, but as long as you remember the 2 cases for the ambiguous, law of sines is probably easier. And then last but not least, 2 sides, not the ambiguous case, law of cosines will be easier. Thomas, you had a question. Go ahead.
How do they get rid of the plus and minus answer?
Plus or minus square root.
If they just went to
Right, because the 1 half came out and then they just made it a plus.
Yeah.
What was the context of the problem? Was there some sort of real world context going on? Yeah, you guys have it written. I don't know. There was something about number 56. What was given to you? Was it just like a picture, or was it like a word problem? Someone give me something. It goes to right directions in your homework, and we have 20-something kids in there.
Engine design.
Oh, engine design. Thanks. Engine design. So it's something practical, right? Okay, so if it's engine design, and what does X stand for? Theta is going to be some sort of angle, but what's the X stand for, Patricia? Do you have that?
The distance the piston moves in 1 second.
Okay, so the distance. Distance, they're just asking how far. I don't think it's like a physics problem where they're asking to the right or to the left. Because in physics, like if you move to the right, it's a positive. If you move to the left, it's a negative. Kind of like our vectors. If our vectors are pointed a certain direction, like gravity we say is pulling down. And so that's a negative acceleration. Whereas if you were propelling something up, that would be a positive velocity. Or I guess if you're launching positive velocity, if it actually has an engine and it's pushing up, it'd be a positive acceleration. But this is just saying distance, which I would assume would be an absolute value, like a positive number only. And so, Thomas, looking at this expression real quick, cosine can only go between 1 and negative 1, right? So the biggest this can be is 3. If I go subtracting something with the square root of 187, I'm in big trouble if I need a positive number. So that's how I would say the plus is the only practical one for the context of the problem. Yeah, good question. I think with that, guys, we're at the end of our evens, right? Since we're grading, let's just keep straight grading into section 6.3 up until, and then you guys have to let me know, which means you have to talk. You get to say something audibly that makes sense in context. Okay. In section 6.3, I want you to tell me when we get there, be like, ooh, I got stuck here. Okay. Number 2, initial then terminal. Those are the points of a vector. Number 8, multiplication and addition. I think scalar, is that what they're talking about? Scalar multiplication and vector addition?
Yeah.
Okay, good. Number 14, the initial point was 0, 0. The terminal point was negative 4, 2. Someone help me out real quick. Could these have been switched and still be right?
No.
Because for vector components, we always do the final minus the initial. Now, I say final because I'm used to physics, sorry. But final, terminal, terminating, ending, finish. Does that make sense? Same thing? Okay. So we always take the latter minus the earlier, or the terminal minus the initial. So if you switched it, you better correct it. That's wrong. It has to be the terminal 1 minus the initial, the terminal minus the initial components. There we go. Magnitude, what theorem are they using? That's just Pythagorean theorem. Good. Simplify the radical. Number 22, same game, right? Same thing. Initial point 111, terminal point 93. Terminal minus initial. Done. Pythagorean theorem. Yeah.
So then in 14, if we just left it 0 to 20, that's the cost.
I mean, you're okay. Just be aware on the multiple choice it'll be simplified or like in the back of the book. Does that make sense? Mm-hmm. But I might make a note of it just so that you remember, like, oh, simplify the radical. Square root of 4 and square root of 5 reduces down. Number 42, they give you the components and they ask you to find the unit vector. Did you guys use our little note in our notes? How do we do a unit vector? We find the magnitude of the current vector, Pythagorean theorem, and we divide both components by it. It was a nice pretty one, so it was super easy. Just divide by 13. And then how do you check that it's the unit vector? Well, the magnitude better be 1. I would just say this is a checking step. They might have told you to check. Did they tell you to check?
Yeah,
Verify. Okay. So that was verifying with Pythagorean theorem. 54. You guys like these ones that were really short? Terminal minus initial and put it with an I and a J? Pause. Do you have little vectors above your I's and J's?
Yeah.
Alright. If not, put them in. Some of you might have been looking at the back of the book and been forgetting that you need little vectors above that. Are we to word problems yet?
No.
So hold on. How on earth did they magically come up with this? Were you given 90 degrees?
Yes.
Ah. Were you given the magnitude 4 rad 3?
Yes.
Yeah.
Okay. What are you supposed to be finding? Components. How did they come up with this whole weird cosine and sine? What is that? What's it called? The formula. Because the formula says if you know the angle, 90 degrees, and if you know the length of the vector is 4 rad 3, then can't you, wait, how do you draw a triangle if the vector is on the axis? You don't. You're just saying, well, the point is 0, and then what's the length? Now, if you use cosine 90, sine 90, the formulas do work, but if you visualize this vector, guys, the point is just, well, whatever the length is, which is 4 rad 3, and then the x is 0, so there you go. It was maybe easier, but maybe even trickier than some of you might have thought. But if it was any other vector, let's say the length was, I shouldn't be writing it here, it's not like okay. If the length is 2 and say the angle was like 45, to find the components, wouldn't I need to use sine and cosine because it's a right triangle? Does that make sense? But you can memorize that formula. What are those formulas? To find a horizontal component with magnitude and direction, what's the formula say? Who is the horizontal? X or Y? X. So X equals, what's the formula say? Is it so easy you guys are just like, psh, I don't want to say it out loud. The X coordinate or the A coordinate or the horizontal component is always magnitude cosine theta. And the Y component, the vertical component, the B is magnitude sine theta, right? Okay, just in case you guys didn't realize those are super important. They're super important. Okay, did you guys finish that one? Now we're to word problems, right? Aha! How hard was 96? Did you get there? Pause. Where'd you get stuck? 85? Alright, so probably didn't get to 96 unless we just kept on going.
Yeah.
Alright. So, since 85 got scary, we got up to 85 though? Does it make sense why we're going to transition real quick to our notes into the example that we didn't get to finish yesterday that was number 89? Oh, alright. Practical application. You got stuck and you need to get further. Practical application. Word problems get hard. So let's do some word problems. Sound good? Okay. I missed the sneeze. Alright. Some of you guys probably need to catch up from yesterday. I was doing this at the end of class, yeah?
Yeah.
So take a second to try to figure out where I am getting these expressions that are on the board. If it helps just a little bit, I suppose I could actually name my vectors. Let's see, I named this one, the blue one, U, V, and I named this one V, R. There you go. So if that helps, we could take away the X and Y. No, I like the X and Y. They're nicer when I plug into the formulas. That's kind of why I'm going to keep the X and Y. They're nicer when we plug in. Because we normally name vectors U and V. The X and Y is going to be the actual lengths. That way I can make it a little bit prettier when I go plugging in my formulas. But it's really just magnitude, cosine, angle, magnitude, sine, angle. Wait, where's 44.5 coming from? Right here, right? The angle of inclination, the angle of elevation from the horizontal of the package to the first crane, and then the angle of inclination from the horizontal to, or the horizon to the second crane. Why did I do 155.7 yesterday? Yeah, and let me explain that really quickly, okay? Are those vectors the tensions of the cables, are all of their components working with each other, so they should be added, or are some of them working against each other, so they should be subtracted? They're working with each other on the box, but the tensions are technically pulling away from each other, right? So if I was to use 24.3, its sine and its cosine would both be positive, and then this guy would both be positive. I would have horizontal components that are both positive, but does that make sense if they're pulling against each other? No, I need to have this guy with positive, and this guy with negative and positive. And the only way to make this guy negative is if I literally put in 24.3 and put a negative sign. Or I just say, hey, let's measure this angle. What on earth is going on outside? Measure this angle in reference to the other one and say, I don't want 24.3, I want 180 minus. Oh, there must be the dogs on campus, something like that. So then coming over here, that might be it.
Joke's on you, can't walk up. Now I saw that.
They're like they're trying to hide.
I'm not trying to hide, I just don't want to see him, I don't want you guys to be distracted by him. Even though they're super loud. Okay, coming back. Give them something to talk about while they're bored outside. So I'm coming over here. If I plug in cosine of the second quadrant angle, won't he be negative? Like I want him to be. Long story short, I need this guy to be working against that guy, otherwise it doesn't make sense. Okay, yesterday I was saying at the very end of class, hold on, I need these two, when put together, to do the following. I need it to cancel out the weight of the box. I need the box to be able to be lifted up and vertically be able to offset the weight. Horizontally, I just want it to stay where it is. So here's the long story short. With these two cranes pulling against each other, if one was stronger than the other, what would happen to the box? Right? It would move horizontally. Do I want it to be moving horizontally?
No.
No, I just want them to lift it. So I want this combined effect to be 0. Horizontally, I don't want it to be moving anywhere. I just want it going straight up. And so if I want it going straight up, I don't want their horizontal tensions, I don't want one to be stronger than the other. I need their horizontal components to basically cancel each other out so they can move up. And what I want for the vertical, I need the combined effect of the vertical tensions to equal this guy, 20,240. Because if they equal the weight, they cancel it out and it's able to be lifted. So in a sense, I need these two cables, once again, horizontally to cancel each other out and vertically to offset the poundage of the box. Now, how can I solve this then? Because I need to get x and get 1. I have two little baby equations, right? Can't I say this guy plus that guy is 0? And that guy plus that guy is 20,240? I have two unknowns, but in this problem I have two variables. No problem. Sorry, two equations. I have two unknowns, but I have two equations, so I'll be fine. So I can go ahead and say y cosine of 44.5 plus x cosine of 155.7 is equal to 0. Now hold on, think through just math. If I'm going to have a system of two equations, what's probably going to be the easiest way to solve if the coefficients are all nasty? Elimination? I don't want to make them match. That's gross. I don't even know how to deal with them. Let's do substitution. So substitution, they want us to find both, so which one do you guys like better? Who do you want to solve for?
0.
Oh, why?
Let's do y. And when we solve for y, can't I say that y is equal to negative? Let's see if this makes sense. Cosine of 155.7 over cosine of 44.5 x. Can I say that? Because I need to subtract this guy, right? Divide that guy. And I just kind of put the x out so that he's separate from all the numbery stuff. Now, why am I not doing nasty decimals? Because I have to go to the calculator. I have to be storing them all because I don't want to round any of them yet. It'd just be so much nicer if I could get it all together at once. So I've solved for y, and what am I going to do with that y? Plug it in, not there. Plug it into the other equation for y. So I can go ahead and say, all right, it's going to be y sine of 44.5. So, all right, fine. Let's take who y is. Let's multiply by sine. So sine of 44.5. Oh, there's going to be a negative. So let's do negative. Times cosine of 155.7 all over cosine of 44.5 times x. So let's see. I took y. With those guys, and I put in the sine of 44.5 also. Good, 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 times x. And then I have plus sine of 155.7 times x equals 20,000. Woo! There we go. Now, I'm going to freeze it so you guys can get it down and show you how we really just need to plug in two things to our calculator to solve. But go ahead and take a second. I froze it so you can still see it. I'm opening my calculator. I have done this so I don't have to plug in lots and lots and lots of decimals. I could have done that. I just didn't want to. Do you guys see two x terms? Hey, me too! What can we do when we have like terms? We don't have to have like coefficients, like terms. Don't we just combine? So how are we going to combine this x guy with that x guy?
Same.
Don't even need a common denominator. We're using our calculator anyway. Couldn't we just think about, for instance, if you want to, can't we just pull out an x? I could do this in one line in my calculator. And I have negative sine of 44.5 cosine of 155.7 all over cosine of 44.5 plus sine of 155.7. Is that true? Can I pull out a common x, or can I think of combining the coefficients if I'm combining my terms? And so what can I ultimately do in my nice nifty calculator? Plug it all in. How? What am I going to do to that whole coefficient? Graph it? Yeah, why don't you just do 20,240 divided by all that jazz? Wouldn't that be nice? If you use your nifty little fractiony thing, you can keep track of it all and not make it super nasty. So 20,240 is the top. The bottom is going to be, let's just get rid of that guy. He's in the way anyway. On the bottom, I'm going to have, well, don't I have another fraction? Okay. So, negative sine of 44.5 cosine of 155.7 all over cosine of 44.5 down the denominator, oops, down the denominator but separate, plus sine of 155.7. Just because I'm paranoid and I don't want to have to do this twice, I'm going to go hit my mode and make sure I'm in, ooh, that was close. I need to be in degree, yeah?
Degree.
Nice. Go. Anybody back me up?
Yeah.
Was it messy? Yes. Could I do it all in one step? Yes. Now, if you don't like that one, you could have right here, check it. If I had to combine like terms, couldn't I have just typed in all of that and then added that, and then we've gotten the x's together? And then I could have hit enter and then do 20,240 divided by that decimal. Yeah, I could have done that. I was just showing you exactly what I was doing. I could have also, up here, I could have technically plugged in each of these guys.
Sorry, Lindsay.
It's okay.
We have the students come on out.
Oh, ours too?
Yeah. All right.
Alright, pausing the videos. Question! We were supposed to solve for x and y, right?
So we plug in that.
So help me out. It beats that option.
No, the dog.
No, it wasn't working earlier. Okay, help me out. Kiddos, if that's x, read it to me really quickly. 15.
15 or 8.
0, 92. We'll count it. What were we measuring the 20,240 in? Pounds. Sorry, it was really small. Pounds. So we'll go ahead and label the X in pounds. But how are we going to find Y? Oh, look! We got this guy. So go ahead and just do negative cosine of 1. You guys go ahead and do it. Negative cosine 155.7 divided by cosine of 44.5 all times the number that you just found. And we end up with Y is equal to
Bless you. Bless you.
785.
Anybody back, Patricia, up? 19,785.832? Yeah. Thanks. Others are coming behind. Alright. You guys good? Couple more seconds if you people are still writing.
Is this pounds of force?
Tension technically, but you could think of it like force. The problem is in physics there are a lot of different units. And depending on the problem you might want, well, just in general, not force specifically, there's like newton meters and joules and all these things. Watts and hertz and yeah. So we're just going with the same unit they have. We're not a full physics class. We're not going to have super crazy many units. All right. Go. Ah!
Oh.
You guys have one of these in homework. I'm almost positive of it. An inclined plane. Someone found one?
Is that 96?
If you are a highlighting kind of person, I would grab a colored pen or a highlighter and highlight this one because it's not. There's a little bit of physics that you need to see in order to be able to solve it. Not a lot. Not even so much physics, just understanding the vector diagram. First of all, you have an object on an incline. The boat is on the slope, right? Okay, the boat is on the slope. Now, I have vectors acting on this boat at the point of contact where it's hitting the ground, right? At this point of contact, we have gravity affecting it. We have the force perpendicular to the surface acting on it. And then we have the force that's pulling it up the hill acting on it. We have gravity, we have the force perpendicular to the surface, and then we have the pulling that's going on up the slope. Okay? So with these three, which one's which? It's going to be very important to know. First of all they told you was that the ramp was inclined 15 degrees. So you can see this picture, but whenever you have any object on an incline, you are able to put that theta as the incline, but wherever the object is on the incline, we'll just use like the center of gravity, wherever it would be. Okay, from this guy we're going to have going down, but down as in down perpendicular to the surface. We have going down as in gravity pulling towards the, well, we could say, I don't know, center of the earth. I don't like that description. But we have gravity that's pulling truly straight down. This one's just down against the surface. And then we have the little guy who's pulling up. Whenever we have this picture, guys, you might be totally confused not knowing anything about this triangle, but the problem is you do know something. Whatever the theta is, whatever the incline is, without having to draw all the different vector diagrams and using geometry to show you, will always end up being the same angle as the angle of gravity to the perpendicular force. So we can steal the incline and put it in the triangle. That's literally the most important thing that you probably need to see. Whatever the incline is, whatever the angle of inclination is, will end up being the same angle as the angle between the gravity force, or the force from gravity, and the force perpendicular to the surface. So, once you throw in that 15 degrees, now we can say, all right, whatever, we got this boxy thing, call that a boat, and then we have a triangle, perpendicular force, gravity force, pulling up the ramp force. We know this is 15 degrees. What else do we know?
90 degrees.
We know this is 90 degrees, that's true.
The other one would be 75.
Yeah, we could find this one to be 75. What else do we know though? We need some sides or else we can't solve. Force of 600 pounds. So where are we going to label him? Is he the gravity one? Is he the force against the surface one? Or is he the pulling one? Okay, do you see which one's which? This one is pulling, right? It's being pulled up the ramp. Or even if it was driving, the engine's pushing it up the ramp. This is what's propelling it forward. So this is our 600 pounds. Does that make sense? What are they asking for?
Combined weight of the load.
What side do you think they're looking for?
BC.
Weight. Weight. What's affected by weight? Now, what if they said something like find the force perpendicular to the surface? Well, then you'd be finding that guy, right? So we don't want to find BC, we want to find AB. Could be the same as AD, but whatever. We want the full, we want the full, like, wouldn't be the same as AD, same direction. We want the full AB. But kiddos, I mean, look at your triangle. Even though the picture is a bit complicated and figuring out, besides the fact that I just told you guys you can always do this, but figuring out why this guy is 15, like, there's some complicated stuff in here, but once you get the triangle filled in, what do we have to do?
Can we do
Sine of 15 is equal to, so can't I just say x is equal to sine, well, 600 divided by, sine of 15 degrees. I'm going to go ahead and quickly open, because I want to make sure that I have the wording, because I just say force perpendicular when I'm talking about the other side, because some of you are like, well, how do I know if it's the other side or not? Oh, we're in chapter 7, not chapter 6. No, we are in chapter 6. And where was my vectory problems? Oh, we're in 6.3. Thank you. I was in 6.3. Combined weight is gravity. Does 96 have? Oh, there's no special name for it. That's okay. The perpendicular force is what you're going to get. Plug in and solve, right?
What is this?
Kiddos, pause. Pause. I know it's just we have to go in the hallway. Pause. We got this. Okay. The hard way of doing this problem, go back up. The hard way of doing this problem is to draw the picture one vector at a time and put them all together and connect and say, okay, geometry, let's go. The easier way of doing this is to make components for each and every one and add them all up. You guys got it? The hard way is the geometry, let's figure out the picture. The easy way is component. Bye guys, see you later. We'll grade word problems tomorrow. Finish up the word problems tonight. As best you can, come with questions. Later,
They didn't get 100%. Yeah, last time Ryan made the curve and he didn't get 100%. Wait, how do you do that?
Okay, so the last one though.
She's very, very bad.